In Chapter 1, pag-uusapan natin yung mga simple stresses. The topics that we are going to tackle here are the following. We have our Topic 1, normal stress, Topic 2, shear stress, Topic 3, bearing stress, and Topic 4, thin wall pressure vessel. So what is a normal stress? A stress is defined as the strength of material per unit area or unit strength. It is the force on a member divided by the area which carries the force, formerly expressed in PSI or pound per square inch, now in Newton per mm square or megapascal. So we have here our formula. Sigma is equal to P over A, wherein the sigma is the normal stress, and P is the applied normal load in Newton, and A is area in mm square. The maximum stress in tension or compression occurs over a section normal to the load. So dito, ang pinag-uusapan natin sa normal stress is that if we have this area and this is the force applied on the area, this force must be perpendicular to the area before we can consider that this is under normal stress. So the force, which is usually applied in Newton, in this area, which is normally expressed in mm square. So we have here the force in Newton and area in mm square. That's why this normal stress is in megapascal. Ayan. So, kukwento muna natin, no? Si Pascal. What is Pascal? Pascal is Newton per square meter. So, maybe narinig nyo na itong kwento na to. Ikukwento ko lang ulit. Merong tatlong magkakaibigan. This is Newton and this is Pascal, and the other one is si Archimedes, para maiba naman. Yan. So nagtago-taguan sila, and syempre sa Tagalog tago-taguan yan. Sa English hide and seek, para social. So si Archimedes yung taya. Ngayon, nung nagtago na ngayon si Pascal. So, drawing natin. Yan. So, tapos dito banda sa may puno. Nandito si Archimedes. Siyempre, bibilang siya ng hanggang 10. Diba? So, kung si Pascal ay nagtago na dito and si Archimedes yung taya, yan. Kaya nung nagbilang na ng hanggang 10, palagay natin mga ano pa lang, mga 7.5 pa lang, wala pong 10. Si Newton ay nandito lang sa likod ni Archimedes. And ito si Newton, ang ginawa niya ay nag-drawing siya ng square. And this is a length of 1 meter and 1 meter. Ibig sabihin, computing for the area, yung tago-tago ka lang, may computation pa, diba? So, area is 1 square meter. Yan. So, pagkatapos ng magbilang ng 10, ay naghanap na ngayon si Archimedes. Ay, di ba yung pinakapatok na mga linyahan ni Archimedes ay, siyempre, ano sasabihin niya? Eureka. I found it. So, hindi nakita niya na ngayon si Newton. Sabi niya, siyempre Tagalog version tayo. Kasi kung sa English, oh, I found you, Newton. You're it. Diba? So, sa atin naman, buong Newton. Ikaw na yung taya. So, sabi ni Newton, wait. Hindi ako ang nakita mo. Kasi, a Newton over a square meter is equal to Pascal. So, hindi ako yung taya, kundi si Pascal. Ayan. So, tuloy tayo. Normal stress is either tensile stress or compressive stress. So, members subject to pure tension or tensile force is under tensile stress, while compression members subject to compression force are under compressive stress. So, if we have here a bar and it is in tension, so how are we going to determine whether the bar is subjected to tension or compression? So, pag tension, we have our force away from the area of consideration, no? So we have opposite force and it's pulling away, no? So it's a pulling force. And the area to be considered here is this, since normal stress says that it should be the force over the area. And this area should be perpendicular with the applied force. So if we have here a tensile force, meaning this bar here is in tension. Now, if we have a pushing force here, pushing, so the area to be considered is this, and this area should be perpendicular to the applied force. And of course, it is also force over area, that is your sigma, or the normal stress. And in this case, your bar is under compression. Now, for the compressive force, this will tend to shorten the member. So, kapag siya ay undergoing compression, yung tendency ay iiksi yung member. And that will be computed sa chapter 2 natin, sa deformation. And if the tension force on the other hand will tend to lengthen the member. So pag hinatak siya, ibig sabihin hahaba yung member. And of course, that will also be computed in our chapter 2. Problem number 1, a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kN. Determine the outside diameter of the tube if the stress is limited to 120 meganewton per square meter, or that's megapascal. So, review. For the formula, we have the stress is equal to force over area, and this area must be perpendicular to the applied force. So if the applied force is 400 kilonewton, the area to be considered here is this. So meaning, since this is hollow, ililess natin sa area ng malaking circle yung area ng maliit na circle, yung area ng butas. So we have the load P is equal to 400 kilonewton, and we have the stress equal to 120 megapascal. So for the area is equal to area nung outside the circle minus area ng inside the circle. So we have area is equal to yung outside, that is pi diameter square over 4, minus yung area ng inside or yung area ng butas, that is pi diameter, which is 100 mm square over 4. Now, since we already have the value of the stress and we have the load P, so sa area, yung ano natin dito is the outside diameter, and that is the required outside diameter. So therefore, makukomplete na natin yung outside diameter. So substituting the value, we have the stress is equal to, so the stress is equal to 120 megapascal. That is equal to P. Your P is 400 kilonewton, since the requirement, if we recall, this force P here must be in Newton, and this area must be in mm square, and this should be in megapascal para consistent yung unit natin. So since this is in kilonewton, and if we express that in Newton, so that is equal to 400 times 10 to the 3 Newton. So this is times 10 raised to 3 Newton over the area. So substitute natin yung area, that is pi d square over 4 minus pi 100 square over 4. Now, solving for the diameter, pwede na natin gamitan ng calculator ito. Ayan, so we have 120 megapascal is equal to 400 times 10 raised to 3 over pi. The diameter, pinalitan natin ng x, square over 4 minus pi times 100 square over 4. Now, solving for the value of the diameter, so shift, solve, equals. And after 1 year, can solve. So, sa instances na kung gagamitin natin yung shift solve function at hindi siya solve ng calculator, so we have to rewrite the equation. So, usually, that is equal to 400 times 10 raised to 3 Newton over 120 megapascal. So we have the D is equal to, so we have pi x square over 4 minus pi times 100 square over 4 equals 400 exponent of 3 over 120. Shift solve equals, and that is equal to 119.35 mm, and this is our answer.